Hi everyone, my name is Kewei and I am a software engineer at Meta. Today I want to talk about an innovative approach towards end-to-end reliability that focuses on user experience and scales across a complicated ecosystem. At Meta, we have a whole suite of apps, ranging from public posting to private messaging. In today's talk, we will focus on the Facebook app because it is the app with the longest history and with a lot of different features to satisfy different user needs. And to set the stage to understand the scope and complexity that we're dealing with in the Facebook app, let's go back to iOS 14 and back in 2020. At that time, the Facebook app's app size is 1.2 gigabytes, and we're constantly among the top 10 apps in terms of app size. We also serve 1.9 billion daily active users with hundreds and thousands of products and features. With all these engaging and complex user experience, sometimes it comes with annoying problems that users are dealing with. So 2 years ago, we started looking at the app house holistically and categorized the user-facing issues into 3 different categories. The first is about the loading speed. This is about users feeling that the app is very slow, things like photos and videos taking forever to load. The second is about crash. This is something that we're all very familiar with. When you are just using an app, suddenly you click something and the app quit entirely. Lastly, it's about bugs. So this is the case where the app is actually not crashing, but you can feel that some of the things are not doing what it is supposed to do. So for example, when you are uploading a photo to your album, that photo is not being uploaded, or when you are typing out a comment and it's not actually posted to the things that you want it to be posted. So all of these fall into the bug categories. In addition to properly categorize the user-facing issues, we also discovered some of the shortcomings with the typical reliability practice. First, we realized we cannot only focus on the top errors. The reason is that the top errors usually comes from the surfaces that are the most popular, such as the groups. And therefore, if you actually look at the volume of the requests and the errors, the error rate is very small. In addition, the user impression of the app house are usually based on the features that are personal to that user. For example, a marketplace enthusiastic user would feel more affected if the items cannot be posted on marketplace rather than occasionally that person's groups is not refreshing. Therefore, the mobile app house team handpicked several distinct and representative surfaces and set goals for those surfaces to improve their performance and reliability. With that initial success, we decided to scale to all surfaces. Hence, that's the birth of App House Federation. We're going to go into the details of what federation means in later slides. For now, I want to give you some background about myself, which also reflect the long journey Meta has been through to improve user experience with performance and reliability. So I joined Meta to work on GraphQL 5 years ago in 2017. GraphQL is an open source query language for web servers. Since then, I've worked on changing GraphQL spec for fast and reliable data delivery and gradually moved to performance and reliability in general on the web. In 2018, I implemented the GraphQL incremental delivery to reduce app latency. This is now officially in the GraphQL spec as of 2021. In 2021, I also gave a talk to the GraphQL Asia conference on the topic of GraphQL error handling done right, which is the precursor to the talk today. Since then, we have achieved quite a few milestones, which boosted our confidence and conviction that federation is the right approach and prop to talk today. Because I've been in the space for so long, I know the importance of clear definitions and terminologies. So let's define those terms before we pick up the story of federation. The first term is web tier. While it is a common term and a very familiar concept to many of you, we want to narrow the scope of the web tier just to the backend machines that handles the requests from user devices, be it a mobile phone, a tablet, or a desktop. With the scope set to the web tier, the backend, the next term is stack. Again, the definition of stack is aligned with industry standard. It is the set of terminologies, frameworks, and languages that powers the app. Commonly, from the top to the bottom, it is your UI framework, data API, cache, storage are the major components. What we want to call your attention to is this tendency to view the ecosystem as horizontal, right, which is the stack. And it is to say that to ensure the reliability of the end-to-end ecosystem, we just need to ensure each layer's reliability is good. Now, the next term, of course, is federation. In the context of App House, federation means a standard set of App House metrics with the responsibilities federated out to the product owners. In the diagram here, we make it very clear it is a vertical approach. Our start point is each distinct product and features, and they cut across the meta stack. If this contrast doesn't resonate with you right now, or you don't fully understand the difference, don't worry about it. We're actually going to the details in the later slides. So now with the terms and their precise meanings defined in the context of this talk, let's pick up the story. So with the federation on the mobile side, we're able to improve the performance and reduce crashes dramatically. However, we haven't been able to do the same for reducing bugs. And here are some insights into why this is the case. In the slide you're viewing right now, we're showing you two different bug examples. Here, our end users describe the same bugging behavior in very different ways. While some people would say something is not publishing, others would just vaguely describe it as my page is not working. So it takes a lot of human effort to read through and understand what is really going on. After our product engineers painfully resolved 30 to 40 severe bug reports, we realized that the majority of the root cause of these bugs actually comes from web tiers, whether it's web tier changes or some of the backend errors. And this discovery really caused us to push the federation from the mobile space to the server side. And let's take a look at how we federate on the web tier. So our principle of web federation is still about laser focused on user experience, although it is a bit hard to do. Because in the way our system is laid out, the web tier is one layer away from our end users. So while our users are directly interacting with the phones, the tablets, and the computers, they're only interacting with the Meta's web servers. So here is what we did to ensure that on the web space, web federation is still focused on the user experience. The first thing we decided to do is to center our metrics on HTTP response code. Comparing to the industry, we see more often errors being categorized on specific error types or error code instead of HTTP response code. The reason that we're using HTTP response code is that it is more aligned with our user experience. As an example, when someone is getting an HTTP 500 internal server error, we know that that user is not getting any data. And it doesn't matter to that user whether it is due to a timeout or an or a Stack Overflow. The second, we normalize the errors based on error rate per endpoint. Recall earlier that we said we're not just going to focus on top errors because smaller surfaces like marketplace or gaming may matter more to a user than a group's timeline. And this is our response to that. We normalize the errors from just error volumes into error rate per endpoint. And the reason that we're using endpoint as a unit of measurement is that we know each endpoint maps to a specific view on the app very nicely. The last point is about triaging regressions. When deciding who do you triage a specific regression to, there are usually two paradigms. The first is called responsibility-based model, and the second is called root cause-based model. In a root cause-based model, the triage is directly to the person who knows how to fix the regression. In our case, this person is usually a backend or a web engineer. Responsibility-based model, on the other hand, asks who owns this endpoint, which typically is a client-side engineer. Across the industry, we see that root cause-based models are being adopted for triaging regressions. However, we're using responsibility-based models and assigning the tasks to the client engineers first, even though we know that eventually the person who needs to fix the task is a server-side engineer. The reason why we triage to client engineers first is that client engineers knows how that endpoint is being used, how the data fetch is being used for rendering, and it allows us to evaluate how is an end user being impacted if an endpoint fails. And it gives us a chance to evaluate the user impact and allow us to reprioritize fixing issues that affect our end users the most. So after we kicked off the Web Tier Federation, we discovered a lot of opportunities to improve App House. We discovered that is a common issue for user-facing bugs. And the company at that time didn't have the right toolings to debug things like or timeouts. We have since then improved the tooling for our developers and empowered them to debug these hard issues. And we have shipped multiple user experience optimizations. For example, on iOS, we have improved the monthly engaged business by 0.215%. On Android, we reduced the number of requests to a specific surface by 9%, all coming from user retries. Also on Android, for photos and videos data log, we have improved their performance by over 90%, so that the user is feeling this surface is responding to them immediately. It is very smooth and fast. Now I want to dive deep into the novelty of the federation approach. If the early slide of the horizontal versus the vertical comparison, you have some questions or not clear of what this is about, hopefully the next couple of slides is going to make that clear. In the horizontal view, which is the stack-based approach of end-to-end reliability, each layer or each service will have an owner who is responsible for ensuring that service is good. As an example, let's say the Facebook app is growing and we decided to add a caching service as an optimization. The cache service owner created some metrics like read availability and write availability. They also give themselves an overall goal on those metrics, such as 4.9 reliability on read and 5.9 reliability on write. Now, from the federation side, we're going to use groups timeline as an example and as a contrast to the horizontal view. The view started on the client side, which has the latency, the crash, and the bug reports as the metrics. Then we trace that dependency down to the web tier. And we have the matching metrics like total execution time. Do you have HTTP 200 errors, which is partial errors? And do you have HTTP 500 errors, which are total fatals? And then we're going to do it all the way down to the storage. So here, instead of looking at the entire DB's reliability, we're just going to look at one specific relation, which is the group users relation, and check if that use case has problems like timeout or throttling. So coming back to the issue that started the web tier federation, which is bug reports. Today, we reduce the number of bug reports significantly, which allows us to set a very strict rule for ourselves to alert us when a severe bug happens. In the past, we have to wait until bug report volume increased to 400% to issue a severe alert. Otherwise, the number of alerts would just go through the roof. And that alert threshold is shown in the red X. Today, we issue the alert as soon as the volume increased by 300%, which allows us to shift left and have early detection. In this case, on the chart below, we actually detect a severe issue 1 day earlier. Therefore, it reduces the duration our users are being affected by a specific bug. Lastly, I want to talk about where we're going next with Web Federation. The first is something I am personally very excited about. There are some challenges with the Web Federation and our plans to go over them. Recall that the responsibility-based triage model assigns the regression tasks to the endpoint owners. The assumption there is that each endpoint will have a clear owner. However, since then, we have discovered some endpoint contains a heterogeneous list of products and features without clear owners. This usually comes from a scrolling experience that you're viewing different things. We're currently in discussion with those teams to figure out a better triaging models for those experiences. The next is about meta at large. The web tier is not where the journey ends. Below the web tier, we have many different distributed systems and services. Our goal is to revolutionize how we do reliability across Meta's distributed stack and push the federation model downwards towards indexing, caching, and storage. This will be an exciting journey with a lot of opportunities ahead of us. All right, that's everything for my talk. I hope you enjoyed the content, and thanks for tuning in.